Thanasegar is working as a lecturer in Department of Information Technology, Anna University, Chennai. He finished his MCA from Urumu Dhanalakshmi College, Bharatidasan University. He finished his ME in Computer Science and Engineering from College of Engineering, Anna University. His areas of interest are multi-core programming and architecture, programming models, compiler, automata theory, cryptography, and algorithms. He is an expert in subjects like compiler design, formal languages and automata theory, analysis of algorithms. His research area is code generation for multi-core architecture.
Welcome to the UGC lecture series on computer science. We are having the subject called computer science, so compiler design. And so we have seen the previous episode how the predictive parsing table is going to be constructed. That is, we have seen the algorithm, but that requires the given context-free grammar. And first of all, we must know that the context-free grammar is free from there is ambiguity. And if the grammar is an ambiguous grammar, then we must go for eliminating the there is ambiguity available in the grammar to produce an unambiguous equivalent grammar. So that is the one. And then we must know that it is going to be a top-down parser. As far as top-down parsers are concerned, so we should not allow the left recursion or left factoring in the context-free grammar. So once we find that there is a left recursion, we will apply the rule required for eliminating left recursion and eliminate them. And similarly, if you find that left factoring is there, then you just remove the left factoring from that. And as a result of that, we will be having a grammar which does not have there is ambiguity and no left recursion and no left factoring. So as a result of this, the grammar being obtained will be subjected for computing the two sets called first set and the follow set. So after doing this, we can go for computing the constructing the predictive parsing table. So here is the procedure available. The steps to be carried out for the predictive parsing table construction are so ambiguity removal if any, and left recursion if any, remove left factoring if any, then compute the first set and then compute the follow set, and you can go for constructing the parsing table. So here you have the grammar. This is the grammar given for you. There is E derives E plus E, E star E, and open E close or ID. This grammar is ambiguous. We know that it is because of it does not maintain any there is left recursion, the priority or associated information for the various operators. This grammar says that both plus and multiplication takes same priority, but actually it is not so. Plus always takes lower priority than this multiplication. That is the point number one. And this point number two is when you are having consecutive pluses, so whether we have to carry out the operation from left to right or the right to left, that is also not mentioned as far as this grammar is concerned. So that is the reason why we go for removing ambiguity available in this grammar. So once the ambiguity has been removed from this grammar, we have the new grammar called E derives E plus T or T, and T derives T star F or F, and F derives opening bracket E closing bracket or ID. So now this grammar has left recursion. So here we find that E derives E plus T is left recursive because of E, and immediately we are having E on the first position of the right hand side, and then T derives T star F, we have that is T, that is the first symbol on the right hand side, which is nothing but the variable available on the left hand side. So we have left recursion here, and rest of the productions E derives T is there and T derives F is there, and F derives open bracket E closing bracket and F derives ID. So these productions do not have the left recursion or even left factoring concept problem. So now after eliminating this left recursion and all, we have the new grammar E derives like you are having T E prime, and E dash derives plus T E prime, and E dash derives epsilon, and the next one is T derives F T prime, and T dash derives star F T prime, and T dash derives epsilon, and finally these two productions same as the one which is given in your given grammar. So F derives open bracket E closing bracket, another one is F derives ID. So now we have to go for constructing the predictive parsing table from this grammar. So before that, we must know that what is going to be the first set and follow set. The first set computation is done here. We compute from this grammar what is going to be the first set. The first of E is opening bracket, as a result of first of E is first of T, and first of T is first of F, and first of F is opening bracket, and first of F is ID. So which gives you opening bracket and ID will be in the first set of F, first set of T, and first set of E also. That is that we are having opening bracket ID here, opening bracket ID, and opening bracket ID. And then when you are computing the first set of E dash, we find that plus and epsilon are the result of first set of E dash. So this plus will be the first one, and since we are having only epsilon here, epsilon is going to be in the first set of E dash. And when you go for T, we have already computed for that, but it is going to be T dash or T prime. We will be having star and epsilon, and finally for F, we know that is already it is computed opening bracket and ID. So that is the first set computation, and now we have the follow set computation. So the same grammar is once again given for you. E derives T E dash, and E dash derives plus T E dash, E dash derives epsilon. So from this, just to recall the there is algorithm which is being followed for constructing the follow set. So the first to be added is dollar, because every string derived from the start symbol of the grammar is expected to be terminated by a special symbol called dollar. So dollar will be strictly following the start symbol of the follow set of the start symbol of the grammar. So we have dollar in this, and because of the tool number 2, we know that the first set of E will be in follow set of T. So first set of E is plus, so plus will be in T, and here first set of star T dash, that is star, so star will be in follow of F, and then closing bracket is in follow of E, and by rule number 3, follow set of E will be in follow set of T, and the follow set of T is going to be in follow set of F, and follow set of T dash is going to be in follow set of F, which does not make any difference, and repeat it, that is until we find that no more inclusion is possible in any of the follow sets. So what will happen here is we will be having the follow set computation, that is as computed here. So follow of E is dollar followed by closing bracket, and follow of E dash is also the same thing, whereas in follow of T and T dash we are having one more symbol called plus, and finally follow set of F, that is having dollar closing bracket, that is plus and asterisk. Now we can think about how the predictive parsing table is going to be constructed. As far as the predictive parsing table construction is concerned, we have already seen the algorithm for that. So it is a table whose name is M, and we are having that is the terminals indexing the columns. So we have plus, asterisk, opening bracket, closing bracket, ID, and the special symbol called dollar. And as far as the rows are concerned, we are having E, E dash, T, T dash, and F. So now the rows and columns have been generated. We find that there are 6 number of columns generated as a result of 5 number of terminals from the grammar and the dollar a special symbol. And there are 5 number of rows being generated as a result of the 5 number of variables available in the grammar after eliminating left recursion and left factoring and all. And now we should know that is how we are filling the various entries available in the that is predictive parsing table. Let us take the first rule. We are having E derives T E dash. As far as E derives T E dash is concerned, what the rule says is, so if A derives alpha is a production, and you write that is A derives alpha in all the intersections where the first of alpha is having. So in this case we should find out the first of T E dash, and the first of T E dash is known that first of T. Since first of T does not have an epsilon, there is no need of going for first of epsilon, first of E dash. So you just compute first of T. So the first of T, that is what which you have computed here. We have first of T is opening bracket and ID, So now as far as this production is concerned, that is E derives T E dash is concerned, it should be written into the intersections E comma opening bracket and E comma ID. There are two intersections in this predictive parsing table. One is E comma ID and another one is E comma opening bracket. So what we should write is E derives T E dash. So that is what here we are having. We have E derives T E dash and E derives T E dash in the row meant for E and in the column meant for opening bracket and ID, as we find that opening bracket and ID are available in the first set of that is T E dash. So now we have applied the rule number 2 of the predictive parsing table construction algorithm to the very first production. As a result of that, we have made two number of entries into the parsing table, one in E comma opening bracket and another one is in E comma that is ID. The second production, it is going to be E dash derives plus T E dash. As far as plus T E dash is concerned, the first set of plus T E dash is plus. Since we are having only plus as the terminal, so E dash comma plus will be the that is the intersection in which we will be writing E dash derives plus T E dash. So we have the entry here, E dash derives plus T E dash. The production itself is E dash derives plus T E dash, and the first set of the plus T E dash is going to be plus because it starts with the terminal. So we will be writing E dash derives plus T E dash in the intersection E dash comma plus. So next, when you are going for that is T derives F T dash, so this is the production we are having. The same thing is to be done. You compute the first set of the F T dash. The first set of F T dash, what it says is that is the first of F. The first of F is opening bracket and ID. The opening bracket and ID are these two intersections. So T comma opening bracket is T derives F T dash, and another one is going to be T derives ID, that is going to be F T dash. So in both intersections, we find that T derives F T dash as a that is entries. That is about your that is row number 3. And next production is T dash derives F star F T dash. As far as T dash derives star F T dash is concerned, by applying the same rule number 2, you just compute the first set of star F T dash. The first set of star F T dash is your star, because it is a terminal, it starts with terminal. So in the intersection where we would write the production is T dash comma star. So we are having in T dash and star, we write T dash derives star F T dash. And when you are coming for the last two productions are F derives opening bracket E closing bracket and another one is F derives ID. When you are considering F derives opening bracket E closing bracket, opening bracket is going to be the first set of opening bracket E closing bracket, and now it is to be written into the intersection called F comma opening bracket. So it is F is the row and opening bracket is the column, so in which we write F derives opening bracket E closing bracket. And the next one is F derives ID. The first set of ID is ID because ID itself is a terminal, and as a result of that, we write F derives ID into the row called F, column called ID. So the intersection is going to be filled with F derives ID. So now we have seen that is how we are applying the rule number 2 to construct the predictive parsing table entries. So next, the rule number 3, what it says is we have few more productions. That is, you just look at the production called E dash derives epsilon and another production called T dash derives epsilon. These are the productions actually that is for which the right hand sides are having only epsilon, which means the right hand side does not have any valid terminal as the first set. We cannot have a that is epsilon as a follow set. So what do you do here is you just compute the follow set of the left hand side, that is here it is E dash and here it is T dash. So the intersection is going to be E dash comma the follow set of that is E dash, and another one is T dash comma the follow set of that is T dash. And on these two that is entries, we will go for adding the that is your entries. So we are having that is the rule number 3 now, that is can be applied on our that is your predictive parsing table construction, but I will just explain that after a short break. Welcome back. We are seeing that is how the predictive parsing table has been is being constructed, and there are two important rules on that predictive parsing table construction. One is the compute the right hand sides first set, and another one is if you find that the first set of the right hand side is not having there is any valid symbol, any valid terminal, that is if you are having only epsilon, how will you do the or how will you make use of the production rule in constructing the parsing table? As far as the right hand side contains only epsilon, and in that case what should be done is you compute the left hand sides follow set. For example, if I am having E prime is epsilon, the right hand side has only epsilon, so the follow set of E prime will be considered as the that is input for filling the table entries. So if I am having two entries like plus and closing bracket or plus dollar and closing bracket, then E dash comma plus and E dash comma dollar and E dash comma closing bracket, we will be writing those productions like E dash derives epsilon into that. So that is what the idea behind filling the that is predictive parsing table, provided we find that is the right hand side has only the epsilon as the first set. So here we can see that how it is being filled. The first one we can take that E dash derives epsilon production. So E dash derives epsilon, the right hand side has only epsilon. So what we should do here is compute the left hand sides follow set. The left hand sides follow set says that closing bracket and dollar are the follow set of E dash. So you go for constructing the entries like E dash comma closing bracket, you put the production called E dash derives epsilon, and another one is E dash comma dollar, you just write the entry called E dash derives that is epsilon. That is about filling E dash, and another one is the T dash derives epsilon. So we have the production called T dash derives epsilon in the given grammar, and the right hand side we find that the epsilon is there which does not have any useful symbol. So we should go for computing the follow set of T dash. The follow set of T dash is plus dollar and closing bracket. So what we can do here is fill up the entry called T dash derives epsilon in T dash plus, that is what we are having T dash derives epsilon here, and the next one is T dash derives epsilon in closing bracket, and the last one is T dash derives epsilon in dollar. So we are having three places where your T dash has been filled, T dash derives epsilon has been filled. One is T dash comma plus, as we find plus in closing bracket, there is a follow set of T dash, and in closing bracket, since we find closing bracket is in follow set of T dash, and in dollar, because of we find closing bracket dollar in the follow set of T dash. So with this we know that the parsing table is available. So if you just recall the there is the parsing table, that is predictive parser structure, there is a stack involved, so which is explicitly maintained by the there is a predictive parsing the parser, which will be that is entering the that is a entries like the right hand side of the productions onto the that is stack, which will actually marking the progress of the parsing process, and there is an input buffer where actually the input being parsed, that is string which is to be verified whether it is accepted by this parser or not. So that will be loaded into the input buffer, and by default we will be having the predictive parsing table. So three data structures are involved as far as the predictive parser is concerned. The first one is the stack, and the second one is going to be the input buffer, and third one is the predictive parsing table. So now the driver program of a predictive parser will consult what is on top of the stack, what is the current input symbol, and based on that it will just do the parsing process. So the algorithm which will be doing that that is your predictive parsing is going to be called the predictive parsing algorithm. So what it will do here is, so we know that the stack is actually going to be initialized with a dollar initially, dollar followed by that is your the E, where E is the start symbol of the grammar, and your buffer is completely initialized with the string which is to be parsed. The string to be parsed will be definitely having only terminals. So, as a step, that is the initial step, what will happen is the driver program which will find out what is on the top of the stack. Certainly it is going to be the start symbol of the grammar, and what is going to be the current input symbol. The current input symbol is going to be terminal, and now the parser will construct or consult the that is a parsing table to find out whether there is any valid entry available there or not. So, here we can see the example here. We have taken one symbol string called id plus id star id, and the stack has been initialized to $e, and now the intersection is going to be E and id. So, since we find E and id is going to be the intersection, so where we have a production called that is E comma id, we have T E dash. So, this is the intersection, and we have the production called E derives T E dash. So, that is what the production being written here. So, what we should do here is the predictive parsing algorithm, what it does is, you take the right hand side, we have to push the right hand side in the reverse order onto the stack. So, what will happen is, the first symbol is going to be the first symbol available on the top of the stack, but this is to be done after that is popping the top of the stack from the stack. That means, the left hand side which we find on the top of the stack will be popped out, and the right hand side which we are that is seeing as the expansion for the left hand side will be pushed inside the stack. So, this E has gone, and T E dash is now available in the reverse order, so that we will find T on top of the stack. So, now we have T comma id, the same thing, we have T derives F T dash. So, what do he do here is, T will be removed out, T has been removed out of the stack, but we will push the right hand side, that is F T dash onto the stack. So, we have F T dash. So, now we are having F derives id. So, this F is on top of the stack, and id as the current input symbol available on the buffer. So, we know that so far now no change has been made as far as the buffer is concerned, and now we find F on top of the stack, id on the current input symbol position. So, the production in the intersection of your parsing table is going to be F derives id. So, the same story will happen, pop F out, push id, we will be having the situation like id on top of the stack, id as the current input symbol position. So, this is a situation where we find no variable on top of the stack, but there is a terminal, and the terminal is same as the terminal available on the current input symbol position. So, to say that the parser proceeds in a successful manner, we must ensure that the terminal exposed on top of the stack is same as the terminal available on the current input symbol position. Here it happens so, that is, we find that id is on top of the stack which is being exposed, and id is the current input symbol position. So, both will be simply removed out of from their respective places, because there is a match actually, which means that a node has been created for this id. We started with the root, which is nothing but your that is E, and then it has been expanded into two number of branches, one is E dash and T, next T has been expanded to T dash comma F, and then F dash has been expanded to id, and now we find that id is a terminal, which means it must be a leaf node. So, once you have reached a leaf node, then there is no further expansion possible. That is the reason why we ignore this id from the stack and delete id from the buffer. Leaving the new configuration, we have $E dash T dash and plus id star id $. So, now what should be done for the next step? That is, where we find that T dash derives plus is there. So, if you find T dash comma plus, then the corresponding parsing table entry, what it says is, so T dash comma plus is going to be T dash derives epsilon. So, now this is to be used for the parsing action, so that is what being used. So, your T dash goes on. So, there are the cases are, we may have a right hand side with the variables, we may have a right hand side with the terminal, we may have a right hand side with even epsilon also. So if you have right hand side with variables, they will be pushed. If you have right hand sides with the terminals, they will be pushed, and at the same time they will be removed when we find a match, which denotes the successful parsing action. And when we find a terminal which has only a pop action, but there is no push action, because epsilon when you push, it does not make any difference. So we will not go for a push action, we will go for a pop action, which will just pop out the top stack, and the process will be over. So now we have E dash comma plus, and we know that E dash comma plus is going to be production plus T E dash, and the plus T E dash will be pushed in the reverse order, exposing T on top of the stack, and followed by T, then followed by E dash. So now we have that is plus T E dash after removing E dash out of the stack, and now we have a plus. The plus and plus will be that is matched. So we find a terminal on the top of the stack, terminal in the current input symbol position, and both terminals are same. If both terminals are same, we know that a root as a leave node has been created. So a leave node has been created means we can simply ignore that particular node because there is no further expansion is possible from that node. So we remove that plus and plus, leaving E dash comma T, and then here we are having ID star ID dollar. So then we have T comma ID. The T comma ID, the production is going to be T derives FT dash, and as a result of that we will be having that is your F on top of the stack. ID will be the one which we will be getting because of F derives ID is the production, and then we will be having E dash derives T dash because of the removal of ID from both stack and buffer, and then we are having T dash derives T dash comma star is there. So which means your T dash comma star, the production is going to be T dash derives star F T dash. So which when we are writing under the reverse direction, we will be having star exposed. So star and star will be removed. Then F derives ID, ID will be exposed, and we find that ID and ID will be removed. So at this stage we find that your buffer is completely empty, but still we have few more variables on the top of the stack, but they all will be removed because of the successive usage of the various productions like T dash derives epsilon, and another one is going to be E dash derives that is epsilon. So finally if you look at that, we have dollar on the stack and dollar on the buffer. So once you find dollar on the stack and dollar on the buffer, which denotes the successful completion of the parse tree or the parsing process. So actually we have started with the stack containing dollar followed by the start symbol of the grammar, and we have loaded the complete that is input string into the that is your buffer, and we have made use of the various parsing actions being mentioned in the parsing table. By repeated application of the parsing actions from the parsing table, after consulting the appropriate that is row and column positions, we are able to produce the parse tree. That is, whenever we see that there are n number of entries in the stack, which means n number of that is nodes are open as far as the parse tree is concerned. Also this is going to be a top down parser which is constructing the parse that is your parse tree in a top down fashion. We started with the root, and we will ignore certain terminals at certain stages. They are all denoting that the leave node has been reached, and rest of the branches will be that is explored further, and finally we will find that all the nodes have been that is converted into leave nodes. At that stage we will claim that the entire parse tree has been completed, provided there is no more symbol available in the buffer. So this was the parsing. So here we have seen only this there was stack implementation, but equivalently we will be having a parse tree. Actually that will be the output. So if all branches have been converted into appropriately the leave nodes, then we can say that the parsing has been successfully completed. So that is about the predictive parsing table construction. So we started with the given grammar, and the two things, we are supposed to compute the first set and follow set. After computing the first set and follow set, we can construct the predictive parsing table, and the parsing table is having some number of entries, and certain entries are empty, and those empty entries are considered actually as the erroneous entries. So an error handling parser will fill those entries with appropriate values, and all the other entries are called valid parsing actions. The accept action is denoted by the presence of a dollar in the stack and dollar on the buffer. As far as the questions are concerned, so you may have you may be given a grammar, and from there you have to find out whether it is possible to construct the parsing table or not. For that we need to find out whether there is any ambiguity there or not. If ambiguity is not there, then we can go for eliminating the that is we can go for finding whether there is left recursion or left factoring. After removing that, you compute first set, follow set, go for the table. Sometimes you will be given a string which is to be parsed. If a string is given, by making use of the entries available in the parsing table, you can go for computing the parse tree. So that is about the predicting to parsing table construction and the parsing. So with this I complete this episode. Thank you all.